record to the cloud. Great. So we're going to be talking about microbits and machine learning. But before we get started, what I want to do is to give you the slides that I'm going to be working off, going to put it in the chat so you can follow along. You will see that most of the slides as we're working, you're going to see that they're not needed after the session. That's my hope. I hope that the whole concept is simple enough for you to implement, but I want you to have them as support, as a crutch. And if you want to follow along with the slides, please do so. Now, the second thing is that I'm going to be asking something of you, of everybody participating today, and this to fill in a survey at the end of the session. I put the link in the chat, and right now you have really good chances. You have a 50% chance of getting a box of microbits that will be sent to one of the participants to the session. All you need to do is to be here and to fill in the survey. So those are kind of the main ideas. The main ideas are, hi Pamela, is that we have the slides that I put in the chat. I'm going to put them again so Pamela can have access to them just in case. Then the second thing is that I put the link to the survey, and then the survey is really important for us as a nonprofit. And with that survey, if you complete the survey and you're here, then I'm going to pick one of you and I'll send you a box of microbits. I'll send you an email to get the address of your school or organization so I can send the box of microbits. The last thing is that please feel free to put things in the chat. I'll be monitoring the chat in my other screen so we can go over that and I can answer questions as needed. You can unmute, you can talk. As I saw Cora, you can react, any of these things, so I know you're there and we can have an interesting session that is interesting and relevant for you. Let's get started. Let me share my screen. I have a few slides, the one that I share, but we're going to be working also outside of those slides in order to try and think as a group and understand more than the process of how do we connect a microbit with the createAI application. I want us to think is why are we doing this? Why our students are doing this? Why don't they just barely code it? What are the differences and what can we learn? So let's get started. Machine learning with microbits, and we're going to present this via createAI. I'll show you all these parts shortly. What do we want to do? Very important, we want to understand first computational thinking 1.0 and 2.0. Why are we thinking about this? Is because they provide the foundational information of why are we using AI in this context. So you can use this with your students to see, can we solve a problem or take advantage of an opportunity with or without AI? And this can help evaluate that part. The second is that if you're microbit master, that's great. But if you're feeling a little bit shaky or you haven't seen it in a while, we're going to cover some fundamental concepts. So don't worry about that. And then the application that we create with the microbit, we're going to recreate with AI. What does it entail to do the recreation with AI? What are the challenges? What are the benefits? And we're going to see the tool. And the last part is that Canada has lots of microbits. V1, version 1. I'll show you what's the difference between version 1 and 2. And this application, createAI, is designed for version 2. But at Digital Moment, we experimented with it, and I'm convinced that version 1 can work up to a point. But I think that up to that point is going to be enough for what you want to transmit to your students. All that to say, I don't want anybody to buy microbits. If you have V1, you're good. If you have V2, that is good. If you don't have, to one of you, I'm going to send 10 microbits. So that's what we're going to cover today. And the first question is that we're going to think, How is it that we learn as humans? How computers learn the way we do? Do they do it the same way? What is this concept of machine learning? How do we capture the information? Do we get machines or computers to capture that information? And if we think about these two questions, they're kind of similar, especially since AI had this big boom with ChatGPT. Things have been a little bit blurry, and we question the way that we learn and machines learn. But as time passes by, we find the nuances in what we consider learning and what we humans can do, and the limitations that machines are showing up to this point. But they can find patterns. They're really good at that. They're very good at making predictions and finding correlations within a lot of data. So that helps to present a perceived way of learning within machines. And that's what we're calling machine learning. A part of AI sometimes is kind of misunderstood as AI is just a subset, is one of the ways that AI can learn, and that's what we're going to explore today. And why do we use with the microbit? For different reasons. Those ones I want to show you more than tell you. We're going to start with the concept of computational thinking 1.0. This is something that we have been presenting, and I know you've seen it as educators for a long time, because this is the main idea or the main premise that we have used to bring code to youth, to students, is to think what is the benefit of learning how to code. At some point, it was to create developers. We needed lots of developers. We still need developers, but now there's a lot of conflict in that area. Then why is this still a viable thing and an important thing for our students? It's because learning to code, like doing math, it creates a certain framework that our students can use to tackle problems and take advantage of opportunities. When we're talking about computational thinking 1.0, we're talking about the composition, and this is really important. You have your student has a problem and they can only see the big problem, and we get overwhelmed, or our student gets overwhelmed by it. If we break it down into smaller parts that are more manageable, we're decomposing that problem. Then we've been teaching our students since kindergarten pattern recognition. That's how we get them into learning the alphabet, how we get them to learn math, all these parts. Then we can find different patterns after we break down the problem into smaller pieces. And then we made an abstraction. Said, okay, I have this problem. I break it into smaller pieces. I find patterns between these things. Can I abstract this problem or solution into something that I can make generic? So that's interesting in that process. And at the end, we make a mathematical representation or a coding representation. This is what we have been doing with coding for many, many years. It's not going away, still a good framework. And this, what we have on the left, is the way of thinking about this from the point of view of creating a program. And this computational thinking 1.0, we call it in terms of creating a program, rule-based. That's a lot of information. I know you know most of it, but I'm going to pause there for a second to see if you have any questions, comments. You can put it in the chat. You can unmute anything you want. I'll just wait for a second. If you started typing, go ahead, continue typing, but I'm going to carry on for now. If I see something pop up, I'll answer it. Now, I want us to think about computational thinking now in terms of let's create an activity. Let's try to solve a problem. Somebody gives us the task to create a jump detector, and we want to do that with a microbit. We want to be able to detect when the microbit jumps or the user jumps while holding a microbit. We're going to try and ideate what does it take for us to do that. So let me move to my other screen, and I have here a make code uh, page. I'm going to open something that is called today, has nothing, it's just an empty project. What I want you to do, you can share this with me, or I want you to start thinking, how can I detect if the microbit is jumping? What can I use within the microbit to detect a jump? You can put it in the chat. You can think about it. You don't need to tell me if you don't want to, but I want you to consider. So Cora says accelerometer. Great. So Cora, you get a cookie. That's great. That's a really good answer. Within the tools that we have with the microbit, we have sensors, and one of them will be the accelerometer. Maybe we can think of a real weird way to detect. Maybe we can say that we have a magnet and we can use maybe the magnetic field detector, and depending how low or strong the signal is, that will be another way. We can use maybe the light if we have something that it just reflects light and we see a different reading. That can work, but it sounds weird. The accelerometer, as Cora says, feels very intuitive because we're detecting acceleration. There are different ways we can do that. One will be the raw way. I can use our own shake block, and then maybe we can select different things, but we want to be a little bit more specific. I'm going to put this block here, this block here. Let me make this a little bit bigger so we can see everything that we have. If we want to be more specific, I can go into input, and we're going to find the acceleration block. And we have this block, acceleration on X. Let's show it with show number. All we're doing is that we want to see on our emulator acceleration on the X-axis. Let's test and let's see if it works. Going to move our accelerometer, our microbit, and it's not showing me anything. Like this should be X. Let's try something else. What am I doing wrong? What am I missing in my code? Why don't I see this number change? I'm sure you had this in your classroom before. It's one of the clear mistakes we made all the time. I didn't mean to make this mistake. I just make mistakes all the time. What is missing? What do I need to change in my code? I hear you thinking. I know it's one of those questions that what is happening is computers are ruthless. They're fantastic, but they do exactly what we tell it to do. So, what we're telling it to do is, you know what, microbit, as soon as you get electricity, as soon as you start, I want you to tell me the acceleration. Because as soon as it starts, we're not moving our emulator or simulator, it shows a zero. So we need to tell it is for as long as you're running, I want you to tell me what is the acceleration on the x-axis. Let's try this. Now I come and move and we get a number. So we get, I'm not sure what is the number, minus 446. So we get a few numbers. This is practical. We know this works, but it's hard to read. It's hard to follow. And if we're going to create a jump detector, what will be the number that we need to use? Let's change our plan. We know the on start might not work. Let's not display the number. Maybe I don't want to see the number in the microbit. Maybe I want to have a log, a track, a record of the numbers that I see in order for me to detect which is the number I want to choose. Let me demo this so it's a little bit clearer. I don't want to display it here. I want to have a log. And that I can do by saying in advance, what I want to do is I want to send information from the microbit to the computer via the cable. But thankfully, we have a simulator that we're going to use first. And I can give this acceleration on X. That could be the name. Let's leave it at X. That should be fine. And what I want that value to be is I want you to show me the acceleration on the X-axis. So we're getting something a little bit better because now the information is not going to scroll, it's going to be persistent. If I click on data simulation, we have a graph and we have the number. Right now it's 0. If I go and move it, I'm getting numbers in my log and I'm getting a visual representation of how the x-axis is being affected. Great. We're getting closer. So we know that we need the accelerometer to detect jumping. Now we know that we can see what is the range we can use, but there are more questions. This is the x-axis. So what if we add more? So we add 3 axes to see which one we want to choose. We have X, Y, and Z. So for the 3 axis. We could have strength in this case. I think it's more important to determine in which direction is the device moving. So if we show data, the 3 are here. Let me make these smaller so we can see the 3 of them. And if I go into the emulator, then I'm rocking left to right, and I see the X at the top is the one that is being affected the most. If I do Y up and down, very good. And I see that Z gives me some readings that are a little bit harder to parse since we're on 2D to gauge the 3D part. Other question. We see that we have X, Z, and Y. And if we're thinking about jumping, this kind of seems to make sense. It's jumping. So we could say, you know what? Up and down is the Y. What other consideration do we need? If we're doing this with our students, what should they keep in mind for this program to work if we're only leaving the Y? Let me put the microbit here as a hint. What do they need to ensure so we always get a consistent reading on an up and down jump? They need to keep it upright. Perfect. I don't have more cookies. You ate the cookie I had, Cora, but very good. That is the right answer because we could say is the Y, but I put the microbit this way, or I put it this way, or I put it this way, is the orientation that the microbit is going to have is going to be important. So this, what I want to show with this process, we haven't gotten to our code, but we're thinking, we're ideating, we're getting to think about the X, Y, and Z axis and how to conduct a proper experiment for us to learn in the process. So all this is going to help us get here. Let me go back, is that we are going with this and we decided we're going to go with the Y. Now to code, let's code this. It's going to be simple. We're going to say microbit if the acceleration on the y-axis is greater than a certain number, show me a jumping. If not, show a sitting or an icon. We can choose whatever we want. We can put this on the side. Let's bring the logic, and we're saying, for as long as the microbit is running, so forever, we're going to be asking a question. That question is, if the acceleration on the y-axis is greater than a certain number, and in the experiments, I did this before many times, and it gives me around 1,150. Gonna make a tiny detour. 1,150, Herman, this sounds like mumbo jumbo. What do you think 1,150 is? Why is this? Acceleration of the microbit is measured as milli-Gs. So it's 1,000 of a G. So it should be 1,000, but there are some little, let's say, inaccuracies within the device or expectations or the way it was calibrated, it goes to 1,100 or so to be at rest. And we want to make sure that it jumps when we want. So it should be 1G, should be 1000, but in order to ensure that we do capture the jump, I'm taking it to 1150. And we can say maybe heart because it's jumping, so the heart is beating when it jumps. And if it's not jumping, we can say select an maybe the turtle. It's just sitting. So we have two options. And now, if right now is the turtle, we see the turtle on the screen, but if I move it, it stays at the turtle. So we're having a new challenge. This one is because the computer is doing things really fast, so it needs some time to process. So maybe we can say, show me the heart, but wait for a little bit. Wait for half a second. Let's try and see if this works. And let's try it now. We have our microbit, we have the turtle, we go up and down, and it doesn't do anything. So this is very frustrating. What we're gonna do, let's go and increase it to 1 second. If not, we increase this number. Let's try it out. No need to panic. Nothing here. So my emulator is not giving me what I want. Let's try and download it to the microbit. Let's see what can we do. Let me get my cable. I have a long cable. That's my superpower in life is a Dollarama cable that lets me have the microbit away from the computer. So we have the microbit. I'm going to download it. Let me connect it. If you need to know about this process, let me know and we can do it a little bit slower or more times. Not a problem if you're not familiar with the downloading. I'm downloading to the microbit. So it's going to take a little bit of time because it's changing a different program that I have that I'll show you that takes a little bit longer to load. So we're going over the process. Our emulator is failing. One of the reasons why it might be failing was because it's changing the images too fast. So we always see a turtle because defaults to smaller acceleration, or it can be because our 1150 is not sensitive enough. So we can play with those numbers until we find a value that fits what we need. Come on, microbit. You can do it. You're almost there. So we're almost there. We're going to try it. We can make adjustments. Uh, let's see. Hopefully it works. We have our microbits flashing, flashing, and we should have the turtle. Let's make a jump, and we have the heart. So in this case, our microbit is working. In our emulator, for some reason, what we're trying to do is not giving us that feedback that we expected, but we are here. We created the program. So far, you might be saying, Herman, it's been like 25 minutes and you haven't shown us anything about ML. We're going to get there. Going to get there very soon. So we're here. And this is one version that I had with maybe drawing the arrow up or a dot. Same idea, even without the timer, and in the microbit kind of works well. I wanted to add it that extra time so the heart or the image persists. Very good. Now, what we need to do is first, what are we doing? We're doing computational one thinking 0.0. We took the problem of jumping. We first deconstruct, decompose. How can we break that problem into smaller problems? First, how can we detect movement? We have the idea accelerometer. Great. How do we use the accelerometer? Then we figure out that maybe the y-axis, as long as we hold the microbit in a certain way, it's going to be the best. Anik says, will this jumping only work on a V2? This is a V1, Anik. This works. We're still doing things that work perfectly on V1. Thank you for asking that question. Not yet V2. V2, we're going to see at the end. Great. I hope that makes you happy because that means maybe you have V1s and you want to use them. I want you to use them. Great. We decompose. Exactly. Good. And then we find patterns. What is the pattern? What is the way that we jump? And then we figure out this part. We created an abstraction that we gave it code that we can use for maybe other things. We have this module, this recipe that we can use to detect temperature, to detect light, to detect magnetic forces, to detect sound, different things. Great. This is 1.0, but you are here for 2.0. Let's take a look. In 2.0, things changing. Is what we're talking about AI is that it creates application or finds these patterns or does all these things based on data. So the process is different. We collect lots of data and provide lots of data to the system. It can be labeled data for supervised learning or unsupervised learning or reinforced learning. Those are not that important right now. Is the idea is we need data and we need data that is representative to what we're trying to create or understand or predict, and it needs to be vast enough so that we don't introduce biases within our data. We're going to see that a practical way to introduce bias and how can we help our students start understanding how the people that create these uh, AI models or machine learning models can prevent data biases. The second is that after all this is given to the machine learning model, starts processing the data. So in that processing data is going to maybe filter, is going to start finding some patterns with the data, is going to start doing those initial steps. Then comes the training data. We gave it the data and go and train. And train in a way is not one-to-one, but in a way is thinking that the training emulates computational thinking 1.0, where is the computer, the system that is decomposing, finding patterns, creating an abstraction, and then creating an algorithmic representation that can make those predictions. And then we evaluate and we continue this cycle. Gonna stop there to see if there's any question, comment, and then we'll move along. Click on the next slide, but if you're typing, thank you for the thumbs up. Now we have a new challenge. We want to create the jump detector. Let's go to make code. Where is my make code? Make code is here. So this is our programmatic solution. How can we, excuse me, how can we not use this programmatic solution, but have a solution that is based on data? So the program can do all those steps. There are some ideas. Maybe we can capture lots of data in one of the uh, computer science structures that they're not that important right now, but there are many structures where we can store data for the program to analyze, but it's not doing machine learning. It's just capturing data. How can it process that data to create a model? And that is why we finally, Herman, finally you get there. We need to use something like createAI. It's like creating a model with teachable machine learning for kids, or more advanced models that are used in the industry, not just in education. This one is created by the Microbit Foundation. I'm going to take you there. I want to show you something that is more as a crutch for you to lean on if you feel uncomfortable, but we're going to see everything on the site. It's a site that is very complete, extremely friendly, and has three things that I love that I'll show you. So the first thing is that it's going to help you and it's going to take you step by step. Going to guide you first. We're still talking about version 1 of the microbit. We're going to go into version 2 after. Having issues. You may have issues. Now it's not that new. It was released, I think, at the beginning of the year, if I'm not mistaken. It's become a little bit more stable, but hopefully I'll find a way to make something crash. But most of the time, when that happens, unplug, plug, If that is not working, plug the microbit and add a regular microbit project, and that's going to clear things up for you. So that is just to ease what happens if things go wrong. Second, these instructions that you're seeing here, you don't need to think about them. I want you to have them in the slides, but this is where we're going to come back after we see all these other ones in a practical way. How do we do that? We go to microbit create AI. I'm going to put it in the chat just in case. And let me tell you first, why is it that I like this so much? It first, it lives on the web, it's open source, and the Microbit Foundation thankfully has been great at not collecting extra information and asking for things. So you provide the link to the students, they can start working right away. First. Second, there's something beautiful. There's no login or sign up. You don't need to remember the sign up for your students. They don't need to remember sign up. It saves projects within the browser, or you can download them. But as you will see today, maybe that is even not needed. But then that lowers the barrier. Then you don't need that issue that, oh, I forgot my password, and then you spend 10 minutes trying to support everybody with their passwords. The other one is a limitation that is an answer to a problem that we've been having with these modules, especially when it comes to privacy and how much can we vouch for every single educational application that is out there, is that it only collects information on movement, X, Y, and Z. Doesn't collect audio, doesn't collect video. It's one of those that would be great if it did, but I understand why. There are technical limitations, hardware limitations, but also there's privacy concerns. You have lots of resources and support here. It's going to show you everything, how to do it step by step. And what we're doing today, the jumping one, is based on an AI storytelling friend, but you have more activities. And if you do something new, share it with me. So this is the website. This is what we use it. I'm going to click on Get Started for us to see how it works. So here we are. In the browser, it says I save a few, so we continue the last session, a session that I save and I have in my computer, but most of you will see new session, and most of your students most likely will see new session. We click there, and it's super clean. Too clean, it's empty. It says, what is my emulator? So that's a catch. There are no emulators. You need to have a microbit in order to do this. We have a microbit connected here. I'm going to disconnect it, and we're going to click on connect. And this is the first part. This is one of those screens that I showed you before in the slide deck. It gives you two options. One is this, where you use one microbit, a computer that has internet and a USB port and web Bluetooth. Most Chromebooks, PCs, and Macs have it. Micro USB cable that you have, and a battery holder. So there's something interesting with this. This is the simplest way. This is the one I'm going to show you today. The other one is using radio. The difference with radio is that if you have a device that doesn't have a Bluetooth connection, you can use two microbits. We're going to go with this one. The instructions are here for both. So we're going to click next, and it says, okay, connect your microbit. This feels exactly like what we do to connect a microbit to download a project. We say next, and it says, I want your computer and your microbit to talk to each other. We're going to pair them. This one is already paired. I'm going to click connect. And then this is where I'm going to tell you that this takes a little bit longer to download because this program is bigger. This program is designed for version 2, so it takes a little bit longer, but a little bit longer is not 1 minute. It's a few more seconds. Keep that in mind. And what this is doing, Herman is going to do an ad. The ad is, please, please don't forget to fill in the survey. I want to send you microbits, but for us to improve what we do and to show to our founders, those surveys are very important. And in the slides, if you want to do teacher training on many different aspects with us, the information is there. Free teacher training. We're funded right now by CanCode until the end of March, so we can do PD training for your school. And then I had a chance to do a commercial. You didn't think I was going to include a commercial here, but we did. Now, this is the new part. This is something that is very exciting, but we don't use that much with the microbit because it has been a little bit hard to integrate. But it says disconnect the microbit and connect it to the battery pack. So I'm connecting my microbit to the battery pack and it shows me that image. Let's see what are we doing. It says next and it's showing me a pattern. So you say, does the pattern on the computer match the pattern on my microbit? Yes, no. Why is this important? I'm here in this room by myself. Most likely you're in a room by yourself. It doesn't matter. But if you have 30, 20, 15 students doing this project, then you want to ensure that they're pairing the right device to the microbit because now this is a wireless connection, is a Bluetooth connection. So if it was different, you can change the image here. That's not a problem. And then you adapt. But I want to match it to the one I have on my microbit. We click next. And now we see the same pop-up, but it says web Bluetooth. And in here, it says wants to pair, and now it says something different. It says Zepep, pair, and oh boy, I click compare, and let's cross our fingers. And as you can see, we're paired. How do I know? Let me make this bigger. At the bottom, now I have my X, Y, and Z coordinates. So the cool thing is that even if you don't go through the process that we went at the beginning, you can still go with your students and get them to think about if we're jumping, what are we going to detect? What is jumping? Is this jumping? This is valid jumping. How are they going to attach this to themselves or to a toy? Or is it going to be tested just with the device? So right now, my microbit is connected live. I'm going to put it down and I'm going to reduce the size. So this is the live graph data that I'm getting. We want to detect, sorry, if it's jumping or not. So we need to create our labels. The classes that we're going to have is, one is going to be jump, and 1 second, I'm sorry, but there. I hope that that's the last thing. So we have one that is jump, and it says, let's collect data. So to record data, let me get my microbit, and I can do it 3 different ways. I go with the third one most of the time, but I want to demo all of them. The first one, I click record, and then it gives me a counter, and then I jump, and it captures the data, and it shows me the data here. We're going to see that how that works. The other one, record 10 samples, gives me 10 countdowns, and then I can do the recording. Or record for 10 seconds, gives me 1 countdown, and I can say, oh, jump, maybe jump fast, maybe jump long, maybe jump in a weird way, and we do, and it's starting to collect. I'm gonna leave one maybe static, maybe one like this. So now it comes the second part. Remember, we collect the data, we label the data. But now we need to ensure that the data that we're providing the model is not biased, is representative on what we want to train, test, and predict. In this case, what I like about using the program is that then you get to decide with your students if this graph is representative of jumping or not. Then they need to say why or why not. In this case, we know that The Y should be moving. This is flat. This is not movement. Take it out. This one, maybe we like, maybe this one we like. We're going to leave a bunch. And at the end, let's leave these ones. Let's see what happens. So we did one. We taught them about collecting data, different ways to connect data, and ways to clean up your data in order to make data that is more representative. You don't need too many samples because this is not a production application. We're going to have challenges. Things are going to look weird. Sensitivity when you start thinking about different applications is going to be an issue, but that's okay. We made the jump. We cannot train yet because we don't have at least another thing to train on. So let me add a second action. Let me put the turtle again. Let's bring, where is the turtle? Turtle here, and let's say that is stand. So it's going to be a stand, and we're going to record. And in this case, once again, let's stand just like this. I'm going to record the 10, and I'm going to move it just a little bit to ensure that it's not a perfect stand. And maybe we do one like this for us to have something that maybe we need to consider if we want to keep or reject as pieces of data. Then we start looking once again at the data. And this seems standing this, no, this was fighting a mosquito or something like that, but then we're good, perfect. So we have this idea of these two labels. How many can you add? I don't know up to how many. I made it work with about 4, still pretty well with some considerations. So let's train it. Gonna click on train the model. Now the model, what is the model doing? Is what we're equating with computational thinking 1.0. Taking all that data, going and trying to do pattern recognition within the data, which one of those numbers fits in what category and how can it adjust the knobs in order to make a correct prediction. And then it gives us this information. So I'm going to take it, going to put it here, and it's standing good. We have stand 99% of confidence. And then what if I jump? Then we have the jump. So in this case, are we succeeding? Yes, the jump is a little bit not that certain. Maybe we could add one that is slip. We have some time, but I think that maybe we move to the next part. I'm going to pause here for any questions or where we at so far and what are the challenges that come next and how can we approach them. So a little pause. If you have any questions, let me know. While you think about it or you're typing, the key part that I want to show you is that the program is extremely easy to implement, to run, and it gives the opportunity to capture data maybe outside. But there's a catch to capturing data outside. And you see the make code blocks, and it says here, edit in make code. The challenge is that if I click that, it's going to tell me, nope, this is Anik where we cannot go past this point with V1. But all we've done, it's very important to help and explain machine learning, to do the testing, to do the training, the data selection, the conceptualizing of why are we doing it. Now, if we want to go forward and take the data and capture it outside and manipulate it in make code, it's going to need V2. Why do we need V2? It's because the universe is unfair. No, it's because V1 doesn't have the capacity to store as much information as the V2 does. So one of the things that V2 included is more memory. So it can save data and it can keep data. That's why we can use V2 to do activities that we couldn't do before, where we can capture information and store information, acceleration, light, all these things within the microbit without having to send it continuously to another microbit via radio. Second is that to do the machine learning calculation within the device, the V1 is not powerful enough. The second version is powerful enough to run this within its limitation. But as we saw, can collect data as long as we're tethered to the computer. So we can do all the experiments as long as we're close to the computer, and the model prediction can be seen on the Create AI app. So I know that would be great if we could bring everything to the V1, but I'm sure that a V1 session, and I run V1 sessions with kids before, and the idea comes through. Now, what do we do for V2? This is where we are at, and we're very sad. Like, what do you mean? Why can't I? So the beautiful part is that to use the V2, things don't change. We can do exactly the same process we had from before. I'm gonna do something risky today, but I feel daring. We're gonna even try to use the same model we had with the V1 to see if we can bring it to the V2. Let's try. But the beauty is that they're fully compatible. So it gives us the idea and what to do. Let's go to the Create AI program. So I'm going to cancel this and let me think, what do we do now? If we go to edit, make code, let's try it. Continue to make code. Let's see what happens. It's thinking. Let's see if it takes us there. So it takes us to make code. We can do things, but we cannot download it to our V1. Can we download it to V2? This is the part I've never tried, but today is the day. So it says this is a V2. How do you easily differentiate V1 and V2? V1 has a flat bottom, V2 has notches at the bottom. So that is the main difference, the way that you can tell them apart really fast. And at the back is the V2 has the little speaker and the V1 doesn't. What do we get? The cool thing is that how did we get here to make code? We got here is because this program is already integrated. I can click and it takes me to make code. And when it takes me to make code, I have an arrow to go back if I want to collect more data or add more examples. And in this case, it's giving me a block that says, you know what? One, machine learning stand, the name of one of the models, or jump, the name of the other model, and it's providing me the icons that we had from the Create AI application. It gives us some extra blocks, but this is the key part is if the text a model or a label within the model do something or stop doing something, or do it for a certain period of time, or use it in an if statement. If you detect this model, that gives you an option to create a longer if statement in order to branch out your application a little bit more. The other one is that I only want this to work if my certainty is 95%. Or you know what? I'm doing something that is artistic, maybe 50% can be interesting and I can see how that works. This can help us complete the program that we created because this should work. Actually, what we have right now, I don't think we need to add much more. We can embellish this, and I have an application that embellishes a little bit, but this is drum roll, everybody. Let's see if this works, taking this as is to the version 2. So I'm going to say, you know what? I'm going to download. Let me connect to the version 2 and is it pair? I just want to click download. It's paired, so it's downloading. Says you want to download your machine learning coding project, and then all these things said, yeah, I want to download it. This is you want to download it to the same microbit, or you have another microbit that you want to download the same thing, not the same one. That's fine. Next, connect. It's gonna be paired already, what we call over the process, and it's downloading. And you can see how much faster it is because the processor is a little bit faster. So let's see, if it works. If jump, I don't see, oh, the turtle is there. Good. I got worried. Let's jump, and we have the house. So the interesting thing is that what we didn't need to do in this case, we didn't need to think about milli-Gs. We didn't need to think about what is the threshold that we want the image to change. We're just giving data. Computational thinking 2.0, we're creating an application that the system is taking data that is representative of what we want to predict, and the system is finding the parameters in order to make it happen, and it creates what we know as a model. So here, this is if the model that we created detects a jump, we show this. If the model that we created detects a stand, it shows this part. So very simple, the transition from 1 to V2. Is this why V2 is great? It doesn't give me much. We were doing this before, like the house or the turtle. No, the reality where the V2 can shine is if you take the microbit, you give it to a kid or to a group of kids, and you send them out. Send them to run, to jump, to do other things, then you're taking the activity out of the classroom, and then it can collect the data and to do different things. Because as you can see, this is happening within the microbit. If I put it on my battery pack, I don't need to be tethered to the computer in order to gather the information. And in this case, we're displaying it. Show me the turtle. Oh, turtle, good. And then is 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 only displaying the image of the turtle of the house, but imagine that we can collect all that data and determine how many times we're jumping, so they can make a race or a jump activity to see who jumps the most. Can we envision something who jumps the highest starts becoming different and harder, but that's maybe ideas to explore. So we saw the process is the same. It gives us this. We could make it a little bit fancier where we keep a counter of how many repetitions are we creating, how many times are we jumping just by adding a variable, and we can reset that number to 0. So this is just a very simple idea of how to take that program and use it after on something that can be meaningful for you and fun for your students. I think we're there. Yes, we're there. Feedback, please don't forget the feedback. I know I'm gonna get 3. I'm gonna share today something embarrassing, and this is being recorded. I'm the worst person in collecting surveys from the whole organization, but you're gonna help me today. So that's one. No, no more of that. In the slides, very important, is the link to createAI. I love they include a glossary that is very thorough and easy regarding AI and AI terms. And the troubleshoot that I told you to disconnect, connect, or enter a new program that is not createAI, kind of to flush the system, they're going to show you those and more ideas there. It's a great resource. Besides that, we do different things for free for now for educators as long as we have the funding for Can Code. And I'm going to stop recording. Let me do this. Can I stop recording? No, stop sharing. No, I wanted to stop recording. Did I stop recording? Stop recording. No, so that's part